LabTV travels to a Navy research lab in China Lake, California, where scientists create tough new materials for the Navy. Whether it's an aircraft carrier, a destroyer, or an F-18, Navy ships and planes need to perform. The Navy uses high-tech systems and equipment, and they're always looking for ways to make things better. That begins with material.
Just like engineers build bridges and design airplanes, so we can also, using the latest in technology, build and design molecules. We can make them whatever size we want, whatever shape we want. So this is a computer tool that we use to help us understand what molecules are going to look like and what their shapes are. So we can rotate these molecules around in 3 dimensions and understand exactly what shape they're going to be like. And we can look at how far apart the atoms in these molecules are. So we can build on a scale that's even 100,000 times tinier than the width of your hair what a molecule is going to look like.
The properties of these tiny molecules will affect the performance of giant structures like ships, planes, and even space stations. They need to be light, strong, low cost, and stand up to water and fire. It takes a lot of time and effort to figure out exactly the right recipe.
We can only make so much of a new material, so we have to test small samples. Otherwise, it's just too expensive and too difficult to work with.
So that's a mixture of epoxy resin, which is kind of like a glue that holds everything together, and carbon fibers, which are very strong fibers. So essentially what we're doing is taking those strong fibers, gluing them together with a weak glue, and so we get something that holds together and is strong at the same time. So we call that a composite when you take 2 different materials, put them together in a special way so that we can get more out of the combination of both materials than we can get out of either one by themselves.
This new composite is put through a lot of torture tests.
First, we have to test and see if the mechanical properties are sound, if it's a strong material, and if it's just too weak, we can't use it, even if it's flame resistant.
The scientists blast the material with a blowtorch and watch what happens. Amazingly, it does not catch on fire. Let's see how they designed it to be fireproof.
This is the resin, essentially. This is the glue part of the composite that holds the fibers together that we tested earlier. This is the one that does not catch on fire. And actually, if you look, you'll notice that the gray segments here are a big part of this molecule. So we know that this particular arrangement, which is called a benzene ring, this is very fire resistant. So we wanted to build molecules that had as many of these units in them as possible. And then what we did was we actually put a special group on the ends of these materials to cause them to link together when they get very hot. That lets us turn the liquid that we use to make the sandwich into a strong solid material that can resist flame and water, just like we showed in the other tests.
This designer composite is strong, lightweight, and flame-proof. It will get a lot more testing, but it's well on its way to becoming a material of the future.
We're starting to think about how we can travel out to the moon and the stars and other planets, all kinds of wonderful things that we're going to do in the next century. All of those things depend on some way in materials and chemistry. And if you're a chemical engineer, that means you're going to be right in the middle of that action, and you get to choose what dream you want to pursue, what your goal is.
To learn more about composites, chemical engineering, and other hot stuff, check out labtvonline.org.